Numbers, data, calculations, it can feel overwhelming, right? But not with NumPy. This powerful Python library takes the chaos of data manipulation and turns it into something so simple, you'll wonder why you ever struggled. Welcome to day one of the 30 Days of Machine Learning series, where we make complex concepts ridiculously easy. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. In this video, we're diving into the world of NumPy. We're going to learn all about how NumPy works, explore its most useful functions, and see how it can simplify data manipulation, especially for machine learning tasks. Spoiler alert, it's way easier than it looks. So, whether you're just starting out or you've been struggling with messy code, stick around. By the end, you'll see how NumPy can change the way you think about working with data forever. All right, first step, importing NumPy, our powerhouse for calculations. Here we're creating a two-dimensional array. Think of it as a table. Let's quickly check the shape of our array. Creating a one-dimensional array. Then accessing the first element. Updating the first element to 10, then displaying the modified array. Fetching the first 3 elements. Creating a new array from index 3 onward. Let's see it. Updating B's first element affects A2, thanks to shared memory. Accessing a specific element here, row 1, column 3. Check it out. Let's check the number of dimensions in our array, just one command. Here we're getting the shape of the array, checking if the length of shape matches the number of dimensions. Getting the total number of elements, and confirming with math.prod. Let's see the data type of our array elements. Creating arrays of zeros, ones, and empty values. Super handy functions. Generating sequences with a range, stepping from 0 and from 2 to 8. Here we're creating 5 evenly spaced numbers between 0 and 10. Creating a ones array with integers, specifying the data type explicitly. Sorting the array in ascending order. Defining 2 separate arrays, getting ready for some operations ahead. Combining arrays A and B into one. Stacking arrays vertically, aligning rows to extend along axis 0. Building a 3D array here. Essentially multiple 2D arrays stacked together to explore higher dimensions. Checking the number of dimensions in our 3D array. Getting the total number of elements and the array's shape details. Reshaping a 1D array into a 2D array. Check it out. Ready for some indexing and slicing. Slicing the array, getting the first two from index 1 and last two. Creating a 2D array here, with rows and columns for structure filtering values less than 5, then extracting values greater than or equal to 5. Adding two arrays element-wise, simple operation to combine values. Subtracting arrays element-wise and multiplying them, straightforward but powerful operations. Calculating the sum of array elements, quick way to get total. Finding the maximum and minimum values in the array. Summing along columns with axis 0 and along rows with axis 1. Scaling each element of the array by 1.6 using broadcasting. Here's a 2D matrix, a collection of rows and columns ready for action. Accessing specific elements and slicing rows from the matrix directly. Slicing the first two rows and selecting the first column. Adding two matrices element-wise. Easy way to combine data. Broadcasting a row to add across multiple rows in the matrix. Creating a 3D array filled with ones. 4 layers of 3 by 2 matrix. Creating an array with repeating values. Ready to find unique items and counts. Finding the unique values in the array. Filtering out duplicates. Getting unique values along with their first occurrence. Indices for reference. Counting the occurrences of each unique value in the array. Reshaping the array into different dimensions, adjusting rows and columns. Creating a 2 by 3 matrix from a range of 6 values, reshaped. Transposing the matrix, swapping rows and columns for a fresh view. Here's a 1D array, ready to be reversed or sliced in any way. Flipping the array to reverse the order of elements, nice and easy. Creating a 2D array here, organized into rows and columns for structure. Reversing the 2D array, flipping all the elements along each axis, displaying the reversed 2D array. Check out how it looks now. Flipping the rows of the 2D array, now the rows are reversed. Reversing the columns of the 2D array, each row flipped individually. Flattening the 2D array into a 1D array, all values in a line. Here's an array we'll work with, ready to be saved and loaded. Saving the array to a file, now it's stored as file name. Loading the array back from the file, here's B restored. Here's a simple array, ready to be saved or loaded as a CSV. Loading data from a CSV file, bringing the content into an array. Accessing the docstring for the max function, let's explore its details. Using this command to access the function's docstring for more details. Let's explore the array by checking out its full docstring. Checking out the function's docstring to see what it does. Using this to get even more detailed information about the function. That's a wrap for today's deep dive into NumPy. You've seen how easy it can make data manipulation, whether you're just starting out or you're already deep into your machine learning journey. But here's the exciting part. This is just the beginning. In the next video, we're leveling up with Pandas, the game changer for working with data in Python. Trust me, once you see what it can do, you'll never go back. So don't forget to subscribe and stay tuned. You won't want to miss how Pandas will take your data skills to the next level. Catch you in the next one.